participate along and learn through it, because at the end of this lesson there will be a quiz, individual quiz to test whether you understand or not on this topic. Okay, for purposes of exploration, I have with me here a plastic carrier with two types of handles. One of the handles is the plastic carrier itself and plastic handle itself, and the second handle is the nylon string. Yeah? And as the load, I'm going to use a textbook. Okay? Okay, you all notice, right? Okay, I'm going to distribute the the plastic bag with two types of handle to you. Okay, and this is the order that we are going to do this individual exploration. Going down the row from teacher's table, I'm going to give you a plastic bag from the first students at the front of the row. You will try the experiment, yeah, to investigate the pressing effect of the experiment A1 and A2, okay, on your fingers. Yeah, investigate it, try it. I notice you are putting your textbook, very good. That's the way, try it. Okay, and then after you are done, you pass to the next student down the row. Yeah, down the row in the same row. Okay, down the row. And then after you have done that, okay, carry on. I'll pass to the next student if you already feel. Yeah, after you have done that, I'm going to pass the string balance to the student sitting at the last row. And then so on and so forth, we will go back to the front of the row to investigate the different kind of experiment. From your activity sheet, you can see that there are experiment B1 and B2, right? Okay, I'll give you a few minutes to investigate. Cannot your finger. Okay, make sure when you're holding it, you're using. If you're using 4 fingers, make sure you're using the same 4 fingers for different types of handle. Okay, the last student of the row already done. Okay, the second experiment, I want you all to measure. Okay, measure the experiment B, I'm talking about. You put one textbook as the load, and then I want you all to use this spring balance. You already have learned how to use the spring balance, yeah, and measure the weight applied, yeah, the weight of the textbook. Okay, and then after that you can borrow your fellow classmates' textbook and try to measure 2 textbooks. What will be the force? Okay, then after that I want you all to again investigate the pressing effect on your fingers. Okay, 1 textbook and then 2 textbooks. Okay? Okay, it's an individual exploration. Make sure you do it on your own, okay, and then we will discuss together as a class. How so far? Okay? Okay, let's go through together. First, we have the one with the plastic handle, right? Timothy, yes. Can you comment, relative speaking, the one with the plastic handle as compared to the nylon handle? What can you comment about the area?
The area of the plastic handle is bigger.
Bigger, right?
Yeah.
Relatively speaking, it is bigger than the nylon handle. So it is bigger. Okay? What about the force? Alan, can you comment about the force between the one with plastic handle and the one with the nylon handle? How about the weight? The weight of the textbook?
They are the same.
They are the same. Okay? So, I asked you all to try out the pressing effect, right, on your finger, right? What do you notice? Which one is more and which one is less? This one, in terms of the one using plastic handle, is the pressing effect more or less?
Less.
Jimmy? Okay, less. Good. Yeah? Because the pressing effect is less, the pressure is also low. Yeah? Then let's go on to the second part. Of course, is the opposite. Yeah, Jimmy, can you comment about the contact area?
Very small.
In this is small contact area, right? And how about the force, Waylin?
I think the force
Comparatively speaking, compared to the first one,
should be the same.
should be the same. Good, because it is carrying a same textbook, right? The same quantity of textbook, so it should be the same force. And what can you comment about the pressing effect? The second one as compared to the first one. Yeah? What can you comment? Alan,
The pressing effect is greater.
the pressing effect is greater, right?
Yes.
Okay. So, since the pressing effect is greater, we can conclude that the pressure is also higher, right? So what is the relationship you notice, Jimmy? In terms, we cannot determine the relationship between pressure and force since it's the same, but we can try to conclude the relationship between pressure and contact area. What is the relationship, Jimmy? Is it directly or it is inversely? One, inverse, right? You notice the contact area is larger, then the pressing effect is less. Thus, the pressure is smaller. When the contact area is small, the pressing effect is higher. Thus, the pressure is high. So, from that, we can conclude that pressure is inversely proportional to area. Right? How about the second part? We have one textbook, okay? And then the experiment B2 will be 2 textbooks, right? So, the contact area, what can you comment about it, Timothy? In terms of the contact area when you did the experiment B1?
Same.
It's the same, right? Because it is the same area of the nylon string that is in contact with your finger. Yeah? So it's the same. How about the force? Kenneth, want to comment? In comparison with the 2 textbook experiment, is smaller, right? Then how about the pressing effect? Can you comment, Jimmy? The pressing effect, is it more or less? I know you cannot feel it, but but I'm sure you can feel it with your other fingers. How is the pressing effect?
Yeah, less.
Yeah, it should be less, right? So because of that, the pressure is also lower. Okay? How about the 2 textbook case? Of course, it's just the opposite. Yeah, but the contact area, since you are still using the same nylon string handle, it should be, what do you think, Kenneth?
The same.
Same, yeah? Same. Okay? And the force, of course, this time round, because it's 2 textbook, the weight of the 2 textbook is higher. So, the pressing effect is
Greater.
greater. Yeah? So, the pressure is greater. So, the relationship, you notice higher force, higher pressure, lower force, lower pressure. So, the relationship is direct relationship. Yeah? So, from here, we can conclude together that pressure is directly proportional to force and inversely proportional to contact area. And we can just put it as pressure is proportional to force over area. Okay? But since under the universal standard, SI unit, the unit of force, the unit of pressure is Pascal. And Pascal is defined as 1 Newton per meter square. Because of that, we can conclude that the definition, the formula for pressure is force over area. So in other words, pressure is the force of an object, in this case your textbook, acting per contact area. In this case, the area where the handle in contact with your finger. Yeah? Okay, before we move on next, last weekend it was a Mother's Day, right? Any one of you celebrate Mother's Day with your mother? Very good. You all are good boys, huh? How about Shelfin?
Yes.
Good, huh? Good girl also. Okay, but hopefully you don't only use one day to appreciate your mom out of 365 days. Yeah. I'm sure some of you help your mom to carry grocery bag when she went shopping. Okay. Suggest ways. Now that you already know the factor that contributes to pressure, suggest ways. How do you lighten the pressure as you help your mom to carry plastic bags full of groceries? Huh? What do you think, Wilin? Huh? You're laughing. What do you think?
The father to carry.
Ask the father to carry. Yeah, but assuming you are the one carrying, what do you think?
Maybe we need to spread over a bigger area.
Spread over bigger area. Good. Any other? Yeah, Alan?
Carry a bag, bring a bag.
Carry the bag.
Carry a bag.
Oh, bag, right? Backpack. Because it's the
You take a
thicker
plastic,
contact
take a
area.
plastic bag to tie up. So I think it's you create a bigger area.
greater area. Yes.
So
Any more? Any more?
Just carry like this. Don't carry like this.
Wow.
Chandra, listen to that.
No wonder you injured your finger. What? Anyway, you carry your finger like this. Okay. But anyway, let's. Now that we have learned that smaller contact area contribute to higher pressure, right? Higher contact area contribute to less pressure. So let us do this MCQ question together. Okay, what do you all think? We will discover the correct answer later together. What do you think? A, anybody think it is A? A? You raise your hand? No, right? Your finger is pointing out. Anyone? A? No. B? How about C? C. Wow, you all are good students, huh? Correct? The answer is C.
C.
How about the second question? What do you think?
C.
Huh? Anyone say A? B? C? C. Okay. Can I have volunteer? Can I talk? I'd like to measure like this. Okay. Come, let's try on one. Okay, you all don't have to come. Yeah? Okay, let's try on one first. What do you think? You put two legs on the top first. Okay, what is the reading? Okay, parallax error, we have learned. Okay, what is the reading?
65.
65, 64, yeah? Okay, let's now raise one of your leg, one of your foot. So A, B or C?
C.
C, yeah, because it remains the same. Okay, this time now let's put two. Is it A, B or C? Let's try C. Okay? What do you think?
60.
60.
The other side.
Okay? Can you shift? Yes. Okay. What is the value?
39.
39. Wow, suddenly Kenneth way less. Right? The other one?
29.
Okay, don't look at the value on the top. That is in pounds.
Oh.
Okay? The value at the bottom. Okay? Thank you, Kenneth. Okay? So, what's the conclusion? What's the correct answer for part? The first question, the correct answer is C. Very good, all of you got it right. The second question, the correct answer is
B.
B, okay? Not C. B is less because your weight is being distributed over two contact area. Yeah? So I hope you are clearer on the difference between pressure and force, which is gravitational force. Yeah? What you measure using the bathroom scale is the gravitational force. Okay? Not the pressure. That's why despite the contact area is still the same, but because when you step on two bathroom scale, the weight is being distributed on two different bathroom scale. That's why it has two lesser readings. Okay? With that, thanks a lot for your attention, class.